So this lesson is our final lesson devoted to something that probably is best if you think of in advance and not too late. So something that takes probably most of the time in software development, the phase called maintenance. So maintenance. What does it mean to maintain software architecture? So that's the topic for today. First of all, maybe it might be get rid of this. There's something, some menu hanging on top of the screen, but it doesn't really matter. Maybe actually, oh, it's gone. Okay, so the first thing is to think just for a moment when actually the need to change a system arises. It's a kind of a trick question. So if you looked at the slides in advance, so I have a ready available answer, and it's as soon as it's deployed. So as soon as you deploy some version, some possibilities for a change or some requirements for a change or improvement come to your mind, or you are asked to do some things. So the moment that you push the button, that the system is deployed finally. So some things might come even earlier, of course. So the actual maintenance, I don't know, might consider maintenance also changing the software from the moment that we consider it is finished. But usually the maintenance is the phase. It's still this is still usually considered development, and the actual maintenance begins from the moment that the system is in use. But a real question for you is, what does it mean to maintain a system? So not necessarily just the architecture, or let's take it kind of as if we are not talking about architecture. We don't know about architecture, just about software development, and the system is being developed, and what does it mean to maintain a system? Think for a moment. Maybe use your channels, your alternate channels for communication, like Discord and such things, whatever, and change few words on this, and then let me know either in
Well,
chat or tell me, or if you have any question to the question regarding the question. So I will prepare a document so that I can write down your answers. Trying to create a new window from this Word window. Okay, but I can see blank document. Okay, so think for a moment, and then you'll let me know. You can say it or put it in chat. What's this? This is not what I want. Okay, let's try it like this. This is a normal document. So the question is, what does it mean to maintain a system? And I'm starting to collect your answers. Or proposals for what does it mean to maintain a system? You remain silent like this, I can start answering the question myself, of course, but I thought you might like to be involved, because then I will know what you're thinking of.
Well, hi, can you hear me?
Yes, hi.
Oh, okay, nice. Well, it depends, but I have been searching because you know that my project has some similarities with this, and it depends. For example, if I have found that in a health system care, for example, they have to update it with all the well, it updates itself with all the data. And for example, if they are experienced like when they are developing the system, they put some information like the main illness, and they have to update it with more of them. I don't know if that has some relation, but um, I think that if you need more options and things like that, you
I
have to
see.
update.
Yeah, maybe what you're talking about, if I'm getting it right, is that the rules might change, and the data that you rely that actually shapes the options in your system, which is actually data, because you can have some options, some illnesses, or some regulations in some legislation systems. I mean, the legislation changes, you might have some other options, so that previously were not there. So
Yes.
I don't know how to call these, but I'll try. Data induced changes.
For example,
Data.
I can send an article
Mhm.
about about this. Sorry, that they use machine learning and deep learning systems in healthcare to detect anomalies, like to predict some illness and things like that.
Okay.
I will send it, and I don't
So
know if
that might be, might come get even further, because this is based on you can share it with us through chat, but I won't have a
yes,
chance to you cannot really study this material now.
yes, just to
Yeah,
like an example.
yeah, okay. So I don't know whether this is what I understood, or it goes even further, because it depends. This depends on learning. So in machine learning, the system might get change. Might become that there might be some changes based on machine learning. Maybe machine learning induced changes. So this changes the application logic to some extent, even application logic changes. These are kind of maybe things that are coming to us, but there might be some more kind of established things, old things that happen or have been happening a long time. So are there any other things? we are talking about what does it mean to maintain a system. So it might be to rerun these things, machine learning things, in order to induce changes or to change user interface. Maybe like this, even change user interface based on data that has been changed.
Maybe fixing the
maintaining-
bugs.
Excuse me.
Yes, Hemendra?
Yeah, so I think maintaining the system means fixing some known issues, also seeing what dependencies have to be updated, and how the dependencies of the system works together.
Kind of updating dependencies, or
Yeah.
okay. What's this? Anything else? I'm collecting also the answers in Slovak. No other proposals. So typically we are fixing issues. So this hides a lot of things. Fixing issues. Issues to be fixed might be errors. So I'm not going to write this. I'm just going to talk around these things. To fix errors, and it might be that we need to fix some things that are outdated. So we need to have them in some other way. They're running good. They're not. The system is not breaking. Like it's running fine. But things have changed, and we need to make changes of this kind. Sometimes then we might think of even updating dependencies. Maybe updating dependencies. This reminds me of if I'm wrong, well, who proposed this? Who proposed this, but whoever wants to add anything to this. But my opinion is that this is also a large issue in itself, or area, because dependencies that can be different dependencies of your system with other system, or internal dependencies within the system. So the dependencies might change, so the components might get updated. Some components might get updated, and they function differently. So you need to revise things with respect to this within your system. This sounds already like fixing the architecture, yeah, and even more outside your system there are other systems, and you're communicating with these systems, and the communication with these systems should also be paid attention should be also paid to this, and things might get kind of changed. Either your system changes somehow, so this makes the problem to other systems, but we are talking more about other systems being changed and creating a problem for your system. So if there is anything else, or if I did not get it right, just let me know, or let us all know. So all kinds of things, and we are also talking about when talking about maintaining a system. It also has to do with how a system is internally organized. When you reorganize a system a little bit to accommodate some changes in the outside world, you are not necessarily accommodating to changes in the behavior of the system. So it will provide the same results, but maybe the interfaces have changed. So you need to somehow change your system, reorganize your system, or sometimes they call it refactor your system without changing its behavior in order to accommodate these changes in the surrounding environment. All kind of these stuff happen, but let's think for a moment about this. What I used this even in the beginning of the lecture. Pull, don't push the principle, and avoiding to produce waste are the things that we talked about. So we don't want to push some things on users and create some things that are not wanted. Then they will become, or simply they will be there with us, and having them around means having to take care about them. And in our parlance now, referring back to the title of the lecture, means to maintain these things. Yeah, so we don't want to produce waste that we will need to maintain later. So we want to make decisions at the responsible moments, or responsible moments. Maybe might be several decisions. So we do not want to wait too long to make decisions. So waiting for the most responsible moment might be kind of losing your life because time goes and you are not making decisions. So what is the most responsible moment? But you can feel that when the moment is sufficiently responsible to make some decision. And architecture is all about making decisions. So these are lean principles, and we talked about lean architecture, and this kind of architecture requires some kind some kind of order, but not too much of order, not the order that will enslave you, but an order, but the order that will make sufficient space for your decisions. It's like not having a kind. If you would imagine, just I'm thinking about the moment about children. So imagine a playground with all kinds of different toys and everything. But you, in order to use these toys, you need to follow strict procedures. And imagine a playground kind of with some things even broken, old, dirty, or whatever, where the children will be happier. So too much, the shiny, polished architecture with too much order that will prevent you from growing your system naturally is an overkill. And it will make you unhappy and your users unhappy and everything. So sometimes even less elaborated things might be acceptable to users. Often, less elaborated things are more acceptable to users than those than kind of new, shiny, polished prisons. Lean architecture. When we have this lean basis, so we talked about this. I'm just recalling this. The same slide. I'm using the same slides that you already seen, but I'm talking about it a little bit differently, from the perspective of maintenance. So in agile software development, also we need this maintenance phase. Then we had this thing related to let me just pop up everything that we have here. That's all. We distinguish what the system is and what the system does from what the system does. So what the system is something that we kind of know from the domain. Sometimes we are doomed to discover the domain. So if it's a kind of greenfield domain, new domain, not previously explored, but typically domains are related to each other, and then if there is some new domain, then it's like some other domain, and we can use this knowledge to establish what the decision what the system is, or the knowledge what the system is. We don't have to go to the end user to ask them to explore to find out what actually. So if you're creating some traditional common banking systems, for example, or some other enterprise systems, you don't really have to go asking people, oh, what is it? What kind of system it is? I never heard of it. And there are some established rules in that domain. Then depends even from country to country or culture to culture. So it's a part is transferable, part is not transferable, but in the given context, if you operate in this domain, then you should know some things. If you don't operate in this domain, then you should learn a little bit from those that operated in this domain, have operated in this domain so far, and publish some things about this. So just as Oscar shared a paper with us now, so developers also should read those papers. This is not kind of that's kind of strict science, inaccessible to non-scientists. So if someone does not feel as a scientist, it doesn't mean that one does not have to pay attention to scientific results and how to use them. And most of these scientific results in the end are applied scientific results. And so it is. So the papers are published like this, and there are many. Then there are many good books and talking to people and everything. So you should prepare for this from other sources before you start exploring the actual specific needs of your say so audience. Yeah. So that's the perspective of what the system does, and then you explore these things, and then. When you think of these two perspectives, we talked about this, but I would like to point out that this what the system is kind of more stable perspective. What the system does is more variable perspective. So it will vary over time, and it will vary from organization to organization. All the while, you can kind of, by knowing what the system is, you can create many similar systems. Like the one that you're currently creating for a particular user audience, and you need to have a way of treating those variation points that will arise. So talking about this or mentioning this, we are actually talking about commonality and variability. And these two perspectives are actually corresponding to what will remain stable. So what the system is. Commonality is rather what the system is, and variability is what is likely to change. So what the system does. But also in what the system is perspective, you also have a commonality and variability, both of them. So some things are variable because when applied to certain contexts, you will decide whether some features are necessary or not. So not everything is necessary from the domain to be present in all the systems that belong to that domain. But still, these things might be corresponding to to this what the system is perspective. So this reminds us a little bit of distinguishing the system architecture and use cases. So if you recall this slide that I was trying to before when you talked about lean architecture, so we would like to be able to modify our systems by adding further use cases. This is not a question just about or the question or just changing user interface. There's a whole lot of other things under each use case, but they should not, adding a use case should not require changing the architecture. Sometimes things happen differently, but at least we should kind of try to minimize how adding a new use case would kind of affect architecture. And talking about this, we have this DCI approach. So this is just to remind you of this, that we can decouple use cases and organize our architecture around them. So that's one thing to consider. I'm not going to talk about this again, of course. And then there's this perspective when we talk about commonality and variability. So software product lines could help us. So I indicated some what are the problems, and I'm not trying to treat them or to prevent them. So ideally, we would like not to have maintenance, but it's necessary. It's actually inevitable part of software lifecycle. Inevitable part of software lifecycle, and we want to make it kind of more pleasant to us, not to be too difficult to maintain the system. So if we use this software product lines approach as an organized approach to limited but powerful and organized approach to software use, you can have an unorganized software use called copy paste. So you copy one thing from somewhere and paste it elsewhere you are using. And this is a kind of carefully thought and organized way of incorporating maintenance into your architecture. So your architecture will be organized in such a way with all these things that you develop in the domain engineering process up here, so that you can adjust this more easily and in a more organized way when the things need to be changed. And for much of the things, you will be able to kind of maintain things, maybe even by switching, swapping components here, down there in this application engineering, although this is meant as a kind of, this looks like a waterfall. Yeah. So, but you can get back and rerun these phases, and you can do this in iterations. So this is just a kind of general scheme, does not preclude the iterative process to be incorporated or performed with respect to software product lines development. In many ways, this is, and rarely this is disorganized. Of course, this is an idealized scheme. It's much more chaotic, this process, and why do we need such schemes like this? Is that they make us kind of at least visualize what we would like to have ideally, and then we can try achieving it, but unfortunately we will miss it. And then we'll have something different, but the vision was like this, and if there was not a vision like this, then it would be a complete mess. Okay, so talking about use cases, there is an opportunity to apply advanced modularization approaches. You might say that I'm just using this notion to hide away directly to avoid directly mentioning aspect-oriented programming. I'm not. Here it is. This notion of aspect orientation sometimes is being reduced to something that is not that is too narrow for this notion. So the community started using advanced modularization instead of just saying aspect-oriented programming or aspect-oriented software development. But maybe it's kind of, it would be better that to stick to this, to not to hide the initial idea. Then we can talk about other kinds of modularization, advanced modularization, whether they fit to this aspect-oriented view of the world or not. One thing with respect to advanced modularization, which is not depicted here, is having an ability to see the system from different perspectives. Like I showed you the scheme of the DCI process, and it heavily relies on modularizing system according to use cases. And we talked about what problems can arise from this, and this is the thing that that kind of is, once you modularize your system according to use cases, you have to learn to live with this. Then sometimes you might like to, you see here this order manager, you might like to see this complete order manager class like this. Sometimes you might like to see it like this. So I'm not correct in I was not correct in claiming that what I'm showing here is not completely is not showing this problem that I wanted to mention. And there are attempts to resolve this by providing dynamically different views of software systems. So at one moment you can see them like this through this place and order use case, and see what all that there is to this use case, and even see it in maybe in one file that would be generated and editable. So you can edit anything, and then you can see it like this. So see the whole blocks of your architecture and everything complete, irrespective of what use cases contributes to them. And if you edit this, then this will be transferred to corresponding use cases. So such systems, there are some attempts, experimental attempts, but no, there are not really such systems. And then you might ask, oh, okay, but what's the basic view? What's the real system? What's the real view? And you will find out pretty quickly that there is no real or right view. There are only different views, and that you can use to your advantage. And this is a thing that we discussed in the lecture related to aspect-oriented software development. So I'm not going to repeat this, but this can help you in maintaining your in being able, even if if you would, even though you would not have this sophisticated system that will provide you with different views on demand, you might decouple things in an aspect-oriented fashion, and so to maintain them more easily, like this modified restock plan, which affects place and order use case, so it's clear of these things. And here you can have different views. Some languages enable you even to compose classes like this, or at least something that some partial classes, or sometimes called mix-ins, or what's the there's one other notion related to this. I can't remember at the moment. Okay, now we'll get back to these solid principles and everything just in a moment. Let me just I have some issue here. So we have 2-3 minutes break. So I will leave this like this, not recording, maybe pausing this. Okay, I can pause this. So just give me just 2 minutes, please. Okay, so I'm back. Sorry for this interruption. So we have here something else to consider. You might recall that there are some good principles to follow when you develop software. You might even recognize some of these principles. So single responsibility principle. So that components or classes should not mess with many things, because then when you put all those things together, it's difficult to maintain them. An open-close principle you might recognize, also a list of substitution principle. All these principles, and there are few more principles, and these are known as solid principles. So easily rememberable or memorizable acronym called SOLID. So your system will be solid if you follow these principles. All these things, when you know them, you might kind of manage to get to the architecture that is highly maintainable. But the question might be how to actually achieve these principles. The principles themselves do not really instruct you on how to implement them. Of course, when you read the literature and examples, you will learn by examples, but the principle itself, when you read it, I don't have here, I could have put here a list of substitution principle. You'll need to read it several, it's like mathematical definition. So you need to read it several times in order to, you may even make yourself memorize the principle. But people do not usually remember these things like by heart. Normally, you can explain Liskov substitution principle. I've explained it many times, and I'm sure that if I would try to explain it now, I would explain it in a then in yet another different way. So the principles itself do not help that much when you do not have examples, and examples are close to here, to patterns. And here's an example of a pattern. So here's the visitor pattern. And the visitor pattern gives you a clue how to manage to have your system more make your system more easily maintained, because you are creating a place where further ways, not to say strategies, or actually operations in general can be added without really changing a particular class that would act as if it has or provides these operations. And this is a thing that you can manage a little bit achieving via this description, but still it's not that easily understandable, and you cannot. This is a kind of a very, very short description. There are longer descriptions of visitor, but still, until you see an example, until you try implementing it and understanding really what there should be done, and what is the twist that you need to apply, and you need to see this best if you see this in code, then it's not really kind of something that you can really follow. So patterns are good, but still you need some examples accompanying them, but they're kind of more understandable or more applicable than principles. And the examples are actually inevitable part of patterns. There's a whole lot of different patterns that can be applied, just like visitor. If you apply visitor, you can you can have your code organized in some way, and then you decide to apply visitor in order to make your code more maintainable. making your code more maintainable is actually, if I get back to these principles, the open-close principle here is directly actually applied or embodied in the visitor pattern. So this is the guide to applying one way of applying or holding to the open-close principle. There are many other patterns like this, like visitor, that can be applied here and there in order to make your system more maintainable. The question might be whether this is good or bad. So this is something to think about, and having this visitor pattern as an example, what do you think? Is it will applying the visitor make your code more understandable, or the opposite, more difficult to understand? If you ever applied the visitor pattern or whatever pattern, or analyzed an example of a pattern, I think you spent quite a lot of time in order to understand the logic of the pattern. So applying a visitor will make your code more difficult to understand. But the paradox is that it will be kind of more easy to extend, because you will not have to ruin or change something that is already there. So you follow this open-close principle that your code is should be maintained in such a way by adding things and not by changing things. Okay, so you'll add further operations, and you will not have to change the things that there are or that have already been set there. So this is one of the things that you can do anyway. So with some consequences, of course, to readability and everything, and less readable code then again is more difficult to maintain. So it decreases maintainability. So you can have to kind of balance these things and calculate what is best for you. So to recap this part, I would say that architectural decisions are not easy to change. Therefore, the architecture should be ready for adaptation and extension as much as it's feasible. Sometimes it's it's never possible to have it fully adaptable and extendable, just like that. Yeah. But if you do not, I already indicated that these patterns that I mentioned, like visitor, could be applied afterwards. So maybe I should have talked about these patterns as applied maybe individually, but in the first place. So as you're setting the stage, as you're developing, not for the to improve the architecture, but maybe you're in a hurry and you don't have time to learn about visitor, but you know how to program things and to make them work. Adding a visitor will not change the behavior of your system. The end user will not know that there is visitor inside of the system. and in the end, actually, the things might get slower with visitor because it introduces yet another level of interaction. So sometimes we don't have time nor money to make architecture adaptive and extensible. In that case, we are postponing these things. We are creating something that is called technical debt. So if you ever came across this notion, technical debt, this is the debt to the technical things that we are delaying, or we do something so to be as good as it's possible for the time being, and things that work rather than they are that are kind of well organized, sufficiently well organized, or organized. We could do better, and we are kind of delaying these things. And then might come time to pay our technical debt by doing something called refactorization or refactoring. You need to reorganize, refactor your system, so put it in some other factors that are put together again, but you do not want, or you're not changing the behavior of your system. And speaking of this, of refactoring, there are some indications that some refactoring needs to be performed. I said reusing might mean simply copying and pasting, so copy paste, but that code will be duplicated. Lots of duplicated code is difficult to maintain. Typically, what you duplicated, very often, when you update one place, you need to update all the copies that you created. So imagine thousands and thousands of copies. You can search and replace things, but this is limited, and not and often these duplicated code samples are kind of a little bit changed for the context purposes. There are different variables, so the thing is the same. The thing is same mostly, but slightly different, and this prevents you from performing a full-blown search and replace. A simple search replace strategy, and there might be even other places that you do not want to change. The duplicated code might be resolved by extracting a method, or you can form template method. So there are strategies for this that you can apply. Also, a long method might not be bad as such, so it's a kind of maybe not a very good way of looking at things, like, oh, I have a long method. Is it understandable? Is it compromising the single responsibility principle? Is it doing too many things, unrelated things, creating kind of accidental cohesion and such things? So then extract some methods, decouple it into several methods. A large class is the same. You can make subclasses there, and this is related, as I said, to single responsibility principle. Switch statements. So complicated your code with many switch statements or if-else statements. Same. Actually, might be avoided by replacing them by using polymorphism. So replace conditional. Conditional is that switch statement with polymorphism. Then you pay pay the price for not seeing the things, how things really happened, because when you use polymorphism, you are not sure what will come in the place of that object that you think you are dealing with. So different kinds. It's polymorphic, different kinds, different shapes, forms might come there. This, when you think of visitor that we talked about, visitor is a kind of a quite sophisticated way of dealing with switch statements. So for those of you who recall my lesson in object-oriented programming, where I demonstrated how a visitor can be introduced into existing code, which was working well, but I was just replacing things in order to have my code more sophisticated and more maintainable in the end. So I was doing refactoring. I started with some switch statements or if-else statements. I don't remember now. I think there were if-else statements. So and in the end, visitor enables you to replace these things, and the mechanism of polymorphism does this for you behind the scenes. There are further things to consider, like data class. If you have a data class, it means it's just a data class and it doesn't have any kind of active methods. So you can move a method to it and make it more elaborated, but this contradicts DCI. DCI claims otherwise, as you remember. You should have dumb objects, dumb data objects, and you have sophisticated use case classes. So not all classes should be wise and have sophisticated methods beyond setters and getters. This all is from Fowler and others, called bad smells in code. So bad smells in code, and there's a step further to this, because you see, we even came here to the idea of visitor, or at least me, but I'm not the only one. This smells like patterns to some extent. Yeah. So there is these refactoring strategies get us back to patterns, and visitor is certainly one of the patterns. And actually, I talked about this in advance, mentioning some further refactoring or maintenance patterns proposed by Bushman and others. Specifically, refactoring to patterns is related to Karievsky, and there the question is then how to apply a design pattern to existing code. So it's not a trivial issue, and there is a certain procedure that can help you, and Karievsky proposed this, and proposed this procedure, but these procedures are specific to patterns, to particular patterns, to each pattern. So each patterns, for each pattern, there are specific steps that you should take. When I recall enforcing or applying the visitor pattern in that my object-oriented programming lesson, also I could derive the process how I applied this pattern there. I was not applying this like that to show the students how to refactor their code, but in a way that could be used for this, but just to see what's the nature of the visitor pattern. But more or less, if I would kind of write down the things that I did, and either upon the given example, or generalizing these steps a little bit. So if you have a class C or whatever, some generic class, whatever class you have, and if you have this method that you need, and so on, such things. So you can express those strategies like this, and this is what Karyevsky did to many patterns. As I mentioned, there might be some problem in applying individual patterns here and there. But what do you think? What's the problem there? This really. We talked about not just patterns, but about pattern languages. And individual patterns, applying individual patterns here and there might break the wholeness of the system. Like you are improving some things, but you are growing things in an unorganized way. So you're not, you don't have a vision of the whole. And this is something that might brings all kinds of problems, and you actually then can make things worse even. So POSA 4, Bushman and others propose that this. Similarly, when refactoring the design of an existing distributed application, you enter the language via the particular pattern that addresses the problem whose current design is subject to refactoring and continue from there. So Bushman would like us to apply part of pattern languages, at least. So do not just apply one pattern, but follow subsequent patterns that elaborate further parts. So applying each pattern brings some consequences. It's a paradox, but by applying one pattern, you actually create further problems, and these problems then are resolved by further patterns, and so on and on. This is how things grow. So no life without problems. You don't have problems the moment that you die. But in life, for life, you need problems. Even after you die, you might have some problems, depending on what your beliefs are. But but for sure, life is about resolving and making problems. These problems are smaller and then resolved maybe in a more pleasant way, but that's how we live. That's how software systems live. So we are talking here about parts of software, part of pattern languages applied. So here is a kind of example. So client dispatcher server and forward receiver patterns, or whatever. I'm not sure that we need to discuss this at the moment. Let's leave it like this, so we get back to this kind of discussion. This is this was about just to mention it. This was just about this the idea of the example itself. Maybe it's not that important at the moment, but by preparing parts of pattern languages, just taking out certain patterns that you need to apply, you are creating some kind of sub language, and you are creating your own pattern language, smaller pattern language. You can even then see that you will add some other patterns there, not previously mentioned by the literature. That's how patterns are intended to be used. So these are not, there are no strict rules, and you are discovering things, and it depends on your context. And then there's a whole another thing that you are well, I know I actually might refer back to this example. I'm not going to study it, but the thing is that here is a description that you are actually how you're modifying your patterns. So this is a this quote demonstrates the uncertainty of what these patterns are by an author or the authors, because he has co-authors, highly experienced authors, Bushman and others, and it's not their weakness. It's actually like from Imposa one, they thought something, and then they came to some other things. So things develop, and and this is not as I said, this is not something that should be limited to development, to general development, but depends on your context, how you see patterns. So the idea is that you will take out some patterns and then create, establish your own understanding in your own group, in your own organization, be it a team or a wider organization, what they are and how to apply them. And in a way, you would refactor patterns. And sometimes you will even discover new patterns within the existing pattern, within an existing pattern. So it's not unusual, and it's normal actually. Pattern languages can be presented as patterns. And we played this with this a little bit in our research here, even, and other authors as well. So this is something to consider, that it's not bad to kind of create specific kinds or derive specific kinds of your patterns based on what you learned from others. Then you kind of make a thing that is highly specialized for your case. So I should go on from here to Conway's law. Conway's law, as you recall, is about how people actually are reflected in software, and this means that using organizational patterns can changing the organization that develops software will affect the architecture of that software. So this is something also to consider when thinking of maintenance. So the maintenance might happen through people, through organizing people, and this is a reference then again back to software product lines, where actually there are different strategies of how you establish software product lines, and depends also relies on people perspective, and apart from this first possibility, which is highly unlikely to happen, so revolutionary establishing your software product line from out of nothing, virtually, it usually comes out of something that you had. So establishing a software product line is, in a sense, refactoring, and this is maintenance. So you're maintaining your, maybe you created a, maybe this is a kind of sophisticated way to pay out your technical debt, say so. So we discussed these things when we talked about software product lines, so I'm just recalling this. So refactoring to software product lines might be a thing to consider. And this is it. We are at the end of what I wanted to tell you in this lecture. So at one point, as I said, architectural decisions are not easy to change. Therefore, the architecture should be ready for adaptation and extension as much as it's feasible. And this other thing that we talked about is that the architecture can be made more adaptive and extensible by refactoring. So if you did not manage to make it sufficiently adaptable and extensible in the first place, then you are correcting this by refactoring at different levels, including people. So we haven't had much discussion during the lesson, but now there's an opportunity to get back to whatever you'd like to have explained better. So any questions or any remarks or your own observations, whatever. Go ahead. I'm looking here in my other display just to check chat, the chat window. Okay, there are no questions. Then let's finish this lesson like this, and we'll meet next week, the same time, the same place, and discuss whatever you would like to discuss. It's called recap or recapitulation, but I would like more to answer your questions. So I'm not going to push anything on you. If I remember something myself, and if I would be feeling as if I created some technical debt or some other kind of debt, if I would be feeling that I owe something to you, some explanation, then maybe I will provide some explanation by myself. But for the moment, I don't see any such things. I could repeat things on and on, but and add some more things, but I would like to offer an opportunity for you to pull out the information from me, so it's demand based. So if you come to that lesson and if you would have questions, you may use the whole time slot, but in the end we might end up with a shorter lesson depending on the impulses from your side. Okay, so I'm finishing with recording. If you have any other individual questions, so I'm here for a moment or two. Just stop me from leaving the room.
No question for me. But for example, if I find like, I don't know if you enter in the article I sent about healthcare system or not, but
no. It might look like that, but I can't perform multitasking like that.
Yeah, don't worry. I know, but it was like, for example, about my project.
Yes.
My project is about a problem in maintaining in the maintenance of deep learning systems. Can it be applied in other, like for example, the maintaining in the problems with deep learning systems in healthcare?
Mm-hmm.
For example, like the article I sent or something like that. In other, I don't know how to say that. In other materials, like for example, education or financial or something like that.
Yes.
Okay. nice.
So
Because
you're looking at how those strategies that have been applied to medical systems can be applied elsewhere, or
no, for example, I'm finding that some of the most important problems in maintenance, on maintenance, is that they have to adapt if they have an update in the system, or they have to adapt the deep learning system. And I want to know if I can search, for example, in other materials like economic, like for us, for example, in a bank, or in some business like SAP.
yes?
So if I can focus on that, because I'm trying to find a lot of information about that, and there are little information about that, about maintenance problems.
You can look wherever you want. So if
Okay.
that's your question, that's actually highly appreciated if you extend your focus.
Okay. Okay.
So
Thank
you
you.
can include all any other, and making analogies to what they do there and so on. So
I
similar, so still kind of deep learning or machine learning. You're talking about machine learning is kind of a new thing, but some things that we know from the past are applicable.
so I can add any information when I justify it. Yes. I mean,
Of course.
if I justify the information and how it's useful for my project, I can add
Yes.
it. Yes.
Yeah, of course. Like you may add, now I'm getting an impression that we are talking about what can you use as text in your project. You can't use what others have done without making a proper reference to
Yes.
their
Yes. I
work.
know. I know. No. No.
Yeah,
Not that. I mean, for example, if I want to talk, like my project is about deep learning system, but if I want to talk about how to use deep learning system, and what are the problems, which are the problems, sorry,
yes,
about the maintenance in about healthcare, um, a bank or something like that, I have to justify why I think it's useful for my project.
yes,
Okay.
yeah, and you can use the arguments that others have had for this.
Okay. Yes, I need
So,
to
of course.
reference, make the proper reference. But
Yes.
okay. Okay. Thank you. For
Okay.
me, it's all.
Welcome. So any other questions, comments? Okay, let's finish like this. So see you next time.